In this video, we are going to go over section 8.3 and 8.4. 8.3 deals with the derivative of trigonometric functions, and 8.4 will deal with the antiderivative integration of the trigonometry function. In last video, we did a review on all those trigonometric functions, how to evaluate the function and then get a value, both in degree and then also the radian mode. So keep in mind, because we are going to be still evaluating, but we are going to add calculus portion in 8.3 and 8.4. So in this first page, you see a derivative rule for all those 6 common trig functions. Sine, derivative is cosine. Derivative of cosine is the opposite, which is the sine, but there's a negative. Tangent, derivative of a tangent is a secant square x. Derivative of cotangent is negative cosecant square x. Derivative of secant is a secant x tangent x. Derivative of a cosecant x is equal to negative cosecant x cotangent x. Now, all these derivative form can be proved, but we are not going to go over the proof in these sections. So if you're interested, you can definitely look at the book to see how they come up with the derivative of such function. But we will not spend time going through all the proof. We'll simply use the formula to take the derivative. So generally, same thing, if you have a derivative of u, you can use a chain rule and then cosine u, and then whatever the function is, you take the derivative. So all the rules that we talked about when we learn in derivative also holds. So recall product rule, and then chain rule, and then quotient rule. So don't forget all those, we are going to be applying that. So let's take a look at a couple of example problems to get familiar with how to take the derivative of trig function. So let's start with the first one. We have derivative of cosine 12x minus 3. So same thing, it's not simply cosine x, we have something inside here, 12x minus 3. So that means we have to use a chain rule. So cosine u and then times du, right? So what is the derivative of cosine? Well, derivative of cosine is negative sine. So we will be applying this one over here. So negative sine u, which is 12x minus 3, and then derivative of this u, which is derivative for this one will be just simply 12. So our final answer is negative 12 sine 12x minus 3. Okay, so that's it. So if you are good at these product, chain rule, and quotient rule, it works exactly the same, except we are having these trig functions. Let's try another one, tangent x. So this one is no chain rule because inside it's just x. So just like when you are taking the derivative of 3x, this constant in front does not get affected. So 15 stays the same. And then derivative of tangent x is secant x squared. So we get the final answer 15, and then derivative of this secant square x. And that's it. Okay. As you practice more, you'll feel a little bit better. So let's take a look at number 3. And also this is a little bit of a variety. So I tried to put a different example. So number 3, we have a derivative of, so take the derivative of negative 3 sine t minus 2t. Now if you look at what's inside of the sine, this requires chain rule. There's something more than just the x. Okay, so we'll apply derivative for that. So this part over here, the constant does not get affected by it when we take the derivative. And then derivative of a sine is cosine x, positive cosine x. So if I take the derivative, my first part is negative 3. This part over here is cosine of u times du. What is my du? If u was pi minus 2t, my du, because it's a chain rule, 3.14 pi is constant, so that disappears. Derivative of negative 2t is negative 2. So I have negative 2. These two I can combine, so final answer, positive 6 cosine pi minus 2t. Okay. Again, this part is cosine u, and then you have to multiply by du, derivative of our chain. Okay. Next page, we have derivative of tangent t, secant t. Now let's recall this one. This is a fraction. This is a quotient, so we are going to be using the quotient rule, right? So let's recall the quotient rule. So if I have a g of x and then h of x, the derivative is low d high minus high d low all over low square. So I'm going to apply that to over here. So let's try that. Derivative of denominator. So we have a h of x, the derivative. Oh, so the first one, we have a denominator times the derivative of the numerator. So I have a secant t, derivative of the top tangent is secant square t. Okay, kind of matching up. I'll color code it. This is my h of x, and then my g prime of x right there. Okay, and this is my g. Minus g of x, which is the tangent t, times derivative of h prime x. So what is the derivative of secant t? Go back to our list. Secant is secant tangent. So this part is a secant t tangent t. Let's also color code it. So we are checking. So g of x right there, tangent t, and then derivative of h prime x is right over here. Okay, all over bottom square. So the bottom one is a green function holding square. So I'm gonna square the secant. So I have a secant square t. Okay, so I have secant t times secant square t. So total I have a secant cube t. Here I can multiply this. So this will make minus tangent square t, secant t, all over secant square t. Now, I can see that I can simplify one of the secant because both terms have a secant. So if I cancel one of them, right? So secant. So this will change it to secant square t, and this one eliminates it. So my final answer ends up being secant square t minus tangent square t all over secant t. Okay. All right. Let's keep going. Number 5, we have something raised to the power. So I'm going to be using power rule. So recall, we bring down the power, so that's going to be 5 cosecant t, subtract by 1, and then take the derivative of cosecant t. Derivative of cosecant t is negative cosecant t, cotangent t. So that will be negative cosecant t, cotangent t. So just combining, I have a negative 5. And then I have cosecant t, 4 of them with another cosecant here, right over here, 4 of them with another one. I'm going to have cosecant to the 5th power times cotangent t. Done. Okay. Number